Everybody's got what they need? All right. Are you good, Malia?
Yes.
Okay. I didn't understand what you said. I'm sorry. All right. I'm gonna look at how to. There's always more than one way to skin a cat. Always more than one way to attack some problems, and some of this stuff you absolutely have to use the sum and difference formulas because there's no other way. But sometimes you do not. So I'm going to show you a couple of problems how to use the sum and difference formulas, and then we'll just decide sometimes if there's an easier way to do it or not. Okay. All right. Let's say I was given sine of 15 degrees. And I'm told to find the exact value of that. Alright, when it says exact value, that means that you can't round. It has to be precise. So if you wanted to, if your calculator was in degree mode and you hit sine of 15, it's going to give you a pretty close answer, but it's irrational, so it's going to round somewhere. So I could get pretty close to it, but I wouldn't be able to get it right because that wouldn't be exact. It's 0.258. It keeps on going forever. Okay? So my options on that then are to check out my unit circle, cross my fingers that 15 degrees is on there. Guess what? It's not. Right? To find, you go from 0 to 30 on there. Right? So we don't have 15 degrees on there. So the sum and difference formulas will let me write 15 as a sum or a difference of stuff that's on my unit circle. Okay, like for example, I've got a 60 and a 45 on my unit circle, don't I? Isn't the sine of 15 the same? Isn't 15 the same as 60 minus 45? So I could say that's the same as the sine of 60 degrees minus 45 degrees. Right? Because 15 is 60 minus 45. Why 60 and 45? Because they're on the unit circle and because that makes 15. Right? Okay, now I know what the sine of 60 degrees is. Look at your unit circle. Sine is the second one, right? So the sine of 60 degrees, let me just make me some notes over here. The sine of 60 degrees is square root of 3 over 2. The sine of 45 degrees, looking at my unit circle, is square root of 2 over 2. Everybody see that? Okay, now I've got sine, I've got subtraction, so I'm looking at my difference formulas. You got that new formula that you wrote down, difference, because we're subtraction. It says I'm going to take the sine. I also need to know cosines, don't I? Let me write some cosines down. Cosine of 60 degrees, cosine is the first one in your parentheses. So that's 1/2. And then the cosine of 45 degrees, looking at my unit circle, is square root of 2 over 2. Alright, so my difference with sine says I'm going to take the sine of A. Here's my A, here's my B, right? So I'm going to take the sine of A, so the sine of 60, so I'm going to have square root of 3 over 2 times the cosine of B. So the cosine of 45, so times square root of 2 over 2. I'm plugging in the difference formula. Minus the cosine of A, cosine of 60, times the sine of B. So the sine of 45.
Can you label those over there?
Say that again, Willis.
Can you label those over there? This one
How?
like the cosine.
Yeah. The ones that's got a 60 in them are A's, and the ones that's got, is that what you mean? The ones that's got a 45 in them are B's?
That's just the formulas and
I got those things over there by looking at my unit circle. Look at your unit circle. So the sine of 60 degrees, remember, it's always cosine comma sine. I don't know what you want me to label it. I don't understand.
did you look at this one?
I'm using this one right here. No, that's sum. I'm using the difference because we're subtracting. Using that one right there.
Okay, so
I used the one that says sine because I had sine. And it was subtract, so you got to do. Alright, so what I've got there to start simplifying this, on the top here, square root of 3 times the square root of 2 is the square root of 6. 2 times 2 on the bottom. Minus, on the top, 1 times the square root of 2 is the square root of 2. On the bottom, 2 times 2 is 4. What's the square root of 6 minus the square root of 2? I don't know. Those are both irrational numbers, so I'm going to leave that as just square root of 6 minus square root of 2 all over 4. That would be the sine of 15 degrees. That's your answer. Okay, now I want you to check that for me. I want you to go back and hit sine of 15 like you did a second ago, and let me see. Okay, let's still got it up. I'm going to say about 2.588. 0.2588. I set my decimal in the wrong place. Alright, so do square root of 6 minus the square root of 2. Hit enter and divide it by 4 and see if you get close to the same thing. Mason's concurring. Everybody else check that out. Same thing. So the dilemma that you have here for you, until you get into college algebra, your major test is ACT or ACT Aspire. Most of the questions, all of them on ACT, most of them on ACT Aspire are multiple choice. So if I had to work this, and this is just me, and I may not be, this will put me in the bad teacher category. If I had to work sine of 15 degrees, I would do it on my calculator, and then I would go through the choices and get the decimal of those and see which one was the same. Because when you do it on your ACT, you're not going to have that difference formula to plug into unless you just got to memorize. And I do, because I teach math. I have more formulas memorized than y'all do, but I don't have all these trig ones memorized because I don't teach trig. Just do a little unit every year, you know what I mean, Vern?
Little units is big.
It has been bigger than some of them, but still not a whole year course like those Stu Dog over there.
I love students.
She cracks me up. Kimmy. That's my friend Kimmy.
She tries so hard to get all my classes.
No, are you in fourth period?
No, I'm in
Fourth period, she tells me horror stories.
Yeah,
about-
that's our class is small, but it's like me and Brooklyn.
She said you won't shut up.
I'm not that bad in
She
that
said
class.
Macy Jones talks nonstop.
I'm not that bad in there.
That's what she said tonight.
Parker and Tristan are worse than me. But our class is annoying.
She
Because
talks
everyone in
about-
the back just like plays their music way too loud and doesn't pay attention. We have like Tristan and Parker and then me and Shakira and Brooklyn and Nikki and like the six of us is probably who listens to the studio. I don't think she likes me. Oh well.
You don't think anybody likes
I
you.
really
though.
don't think she likes me though.
Alright, let's do one more using that stuff and then we'll
What is that
explore.
picture?
That says tangent of 7 pi over 12. And the directions are the same, give the exact answer. So that's in radians. So in a minute when we want to check our answer, we'll have to make sure that our calculator goes to radian mode. But let's figure it out first off. Alright, I'm looking at my unit circle. At my radians, I got pi over 6, pi over 4, pi over 3. I don't have anything over 12. So 7 pi over 12 is not on my unit circle. I got to figure out if I can use some of those measures that are on there to make a 7 pi over 12. Since it's a denominator of 12, I'm going to be drawn to the ones that's got a 3 and a 4. That's just me, because I know 3 times 4 makes 12 pretty easy, doesn't it? So I wonder what if I wanted to make, let's say something over 4 plus something over 3 equals 7 over 12. Okay, this one you'd have to multiply by 3, right? So I wonder what about 3 over 12. This one you'd have to multiply by 4, so what about 4 over 12? That makes 7. Okay, so what times 3 equal 3? 1. What times 4 equal 4? 1. So do I have a 1/4 and a 1/3 pi? Ding, 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 yeah I do. Okay, look in quadrant 1, you got pi over 3 and pi over 4, don't you? Okay, hold on, simmer down. We're gonna keep the radians going.
That's confused.
This is 7 pi.
degrees. Yeah,
Yeah.
could you do that?
You could, but I'm going to leave it in what they gave me. I'm not going to do more work than I need to. Alright, so we're looking at now, we know that pi over 3 and pi over 4. If we add 1/3 plus 1/4, that gets us 7/12. That's what we've discovered so far. Our ordered pair for pi over 3 on your unit circle is 1/2 and the square root of 3 over 2. So there's your cosine and sine. Pi over 4 is square root of 2 over 2 and square root of 2 over 2. Right? Alright, now we added these, so look at the sum formulas, and we're on tangent, so it's the bottom one. It says the tangent of A plus B, so I'm saying that I'm finding the tangent of pi over 3 plus pi over 4. So this is my A, this is my B. Now you can flip those. If you put the pi over 4 first, you'd still work out right. Okay, it says that I'm going to put the tangent of A. Okay, so first of all, I got to figure out what these tangents are. Tangent is sine divided by cosine, isn't it? So of A, that'd be square root of 3 over 2 divided by 1/2, sine over cosine. Dividing by 1/2 is the same as multiplying by 2, isn't it? Hello?
Yes.
So that would be 2 square roots of 3 over 2, and the 2's would cancel. Y'all, there's some scratch work there. That's not anything new. Y'all will be to figure that out. If I had the square root of 3 over 2 and I multiply that by 2 over 1. Let's see what we did. Square root of 3 is left. So the tangent of A is the square root of 3. Okay, this one is easy because it's square root of 2 over 2 over square root of 2 over 2. It's something divided by itself. So the tangent of B would be 1. Thank you, Gracie, for having some sense there. Alright, so
Wait, what's the sense? Where did you get one?
square root of 2 over 2 divided by square root of 2 over 2. Something divided by itself is always 1. You got it, dude. Alright, so it says the formula for sum of tangent says the tangent of A, which we've got square root of 3, plus the tangent of B, which is 1, over 1 minus the tangent of A, which is square root of 3, times the tangent of B, which is 1. Okay, so that's square root of 3 plus 1. On the bottom, when you multiply something by 1, it doesn't change. So we're tentatively, I'm going to put it in a dotted rectangle, we're tentatively looking at that as our answer, but that's not finished. Back to first semester rules, that's not finished because we got a radical on bottom. So we got to get rid of that radical on bottom. We can't just multiply it by square root of 3 because it's a binomial. We talked about this yesterday. You can clear out the radical on bottom when it's a binomial if you multiply by its conjugate. Just change the sign. So I got to multiply this by 1 plus the square root of 3. This was earlier in the year, and I reminded you yesterday. Whatever you do on the bottom, you got to do on the top too. Whoa, that wasn't good. There we go. All right, so we got a FOIL top and bottom now. Y'all ready? 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 All right. Square root of 3 times 1. Square root of 3. Outer square root of 3 times the square root of 3, which is 3. Inner 1 times 1. And last 1 times the square root of 3. Square root of 3. So what we got on the top, you got square root of 3 and square root of 3. That's 2 square roots of 3. And then you got 3 and 1. That's 4. Okay, now we got to FOIL the bottom. First, 1 times 1. Attaboy. Outer, 1 times the square root of 3. Okay. Inner, negative square root of 3 times 1. Negative square root of 3. And the last, positive times the negative, square root of 3 times the square root of 3. There you go. So these, square root of 3, negative square root of 3, he gone. 1 minus 3 is negative 2. Now both of these, negative 2 will go evenly into both of those, so we're going to go ahead and reduce it. So to make negative 1 square root of 3 minus 2. Just divided them both by negative 2.
Where did you get the 2 square root of 3?
from the top.
Uh-huh. 1 square root of 3 and 1 square root of 3 is 2 square roots of 3. And then 3 plus 1. Bless you.
I'm good at physics. I'm not 70. All of that.
Ginormous. Now again, that's something, if I were doing that on the ACT, I would do decimals and check the choices and see which one had the equivalent decimal. But I would have to make sure this time my calculator was in radian mode, so you got to be able to go back and forth between degrees and radians. That's one of the things Miss Stewart always panics about. So I hope they remember to put their calculator in the right mode. Me too. Bad, Leroy Brown.
Here's the tan some formula.
Yes, ma'am, I showed you.
Wait, so
Alright, want to show you now what I was talking about. There's more than one way to do stuff. This next problem I want to give you, this unit suggests that we use the sum and difference formulas to do this, but I did not. So I want to show you some stuff. I know that I've got an angle, cosine of angle A, you can put a theta in there if you want to, is equal to 4/5. And they've always got to tell you what quadrant you're in. So this angle is between 0 and pi over 2.
So
All right.
what's the quadrant on?
I also know, we'll give you a couple things here. I also know that I got another angle, angle B, and the sine of it is negative 15/17, and B is between 3 pi over 2 and 2 pi. Okay. Reason that's important, we talked about that yesterday, we have to know when we're positive and negative. Okay, so here's what we're asked to find out of that. We'll just do an easy one to begin with. We want to find, the question says, what's the sine of A plus B? Okay, now, you've got a sum formula, you could go to town right now and use that and it wouldn't be that big a deal. I'm thinking if I were to have to work this on my own, I already know the sine of A, the sine of B, they gave me that. I could find the sine of A pretty stinking fast because this cosine, remember your ratios, OH, AH, all that, right? Cosine is adjacent over hypotenuse. All I need to find the sine is the opposite. So I can do Pythagorean theorem real quick to find the opposite for that triangle, can I? And you know it because it's a Pythagorean triple. It's the most common one there is. What's the opposite on this triangle? 3. Very good. If you don't know it, do the Pythagorean theorem. It's okay. But it's 3. So the sine of A would be 3/5, right? The sine of B, they already told me. So now I just got to figure out what 3/5 plus negative 15/17 is. So that's not pretty. It's going to be an ugly fraction. So do that on your calculator. The common denominator would be like 85, I think. Get math in your
Yeah,
inner.
negative 24 over 85.
Negative 24 over 85. So we're now looking, bless you, we're now trying to figure out what is the sine of negative 24 over 85. And I would just do that in my calculator.
In degree mode or radian mode?
We would be in radian mode on this, and how did I know to tell Kylie that? Based on these increments they gave me.
No.
Yeah, they're in pi. That's radians. What'd you get?
Yeah, negative 27.
So we'll say about negative 0.28. That'd be all right.
So did it tell you that you were looking for this What did it? What was
This was the original problem. Find the sine of a plus b. So we found a plus b and then found the sine of that. Hold on a second. I might have done something boneheaded. Let me think for a minute. No, that's good. That's good. The sine of A is 3/5. Right? The sine of B is negative 15/17. So once I add those, I don't have to go do the sine of them. That is the sine, right? We did extra work on that. Y'all check this out. We did extra work. Rewind here. The sine of A was 3/5. True? The sine of B was negative 15/17. So those are the sines. All we got to do is add them. So we didn't have to do that. I did extra work for no reason. Stupid.
Remember, so you saw the thing.
Because those are, I went and found what the sine of a sine was. I doubled up. Don't double up.
Oh, never double.
That's right.
Unless you want cheeseburger.
That's funny. Well, you had a knee slapper.
So it just gave you your cosine, so you knew your adjacent and
Alright, I want to do one more since I confuzzled you on that one by doing too much. Make sure I don't do too much this year. Let's look here. Get some closure out of that nonsense. I know the sine of theta is 1/4. Theta is between 0 and pi over 2. I want to find, this is too easy. I want to find the cosine of theta.
Is that a theta? Whatever sign, greater, less than
0 is less than theta, less than pi over 2.
So couldn't you just do that?
So we know sine is,
I have a question.
Go ahead.
Why do they give you where it is? Like,
Because we'll have to check and make sure if our cosine needs to be positive or negative. Okay, so we got opposite over hypotenuse. Cosine is adjacent over hypotenuse, so it's going to be something over 4. I just got to figure out what the adjacent is. So Pythagorean theorem, 1 squared plus I don't know squared equals 4 squared. 1 plus x squared is 16. X squared is 15, so 15 doesn't have a perfect square in it, so that would just be square root of 15 over 4. Okay, now, this is what Kylie was talking about. Does that need to be positive or negative? Well, if I'm in between 0, which is here, you look at your unit circle, pi over 2, which is here, I'm in quadrant 1. To get there, I went right and up. Everything's positive there, isn't it? So I'll just leave that at positive square root of 15 over 4. That problem, this section, would have done some formula on that. That would have been way harder. Just because I don't memorize those very good.
I know, I see.
Alright, let's do one more that's a reciprocal one. We haven't done a reciprocal one yet. Let's look here at secant of theta is negative 7/3. We are between pi over 2 and pi. We're asked to find cosecant. Alright, so first off here, secant is the reciprocal of which one? Sine, cosine, or tangent? Cosine, and cosine is adjacent over hypotenuse, so that means this is hypotenuse and adjacent. Right? Everybody okay? Cosecant is the reciprocal of sine, which is opposite over hypotenuse, so I want hypotenuse over opposite. So I'm going to be 7 over something, right? Y'all able to follow?
Yes.
Alright, so I got 3 squared plus I don't know squared equals 7 squared. 9 plus I don't know is 49. Subtract your 9. I don't know squared is 40. Now when we square root that, there is a perfect square that goes into 40. It'd be 4 times 10, right? And what's the square root of 4? 2. So that will be 2 square roots of 10. Okay, so go ahead. That's a 1. I was trying to write 40 and I screwed up. 4 times 10. Alright, so we've got here 7 over 2 square roots of 10. But we can't leave a radical on bottom. Luckily this time that's not a binomial, so we don't have to multiply by the conjugate. We just got to get rid of square root of 10, so we're just going to multiply, bless you, by the square root of 10. So on the top, 7 times the square root of 10 is just 7 times the square root of 10. On the bottom, pay attention with me here. Square root of 10 times the square root of 10 is square root of 100, which is 10, right? And then there's still a 2 there. So times 20.
How'd you get that again?
Square root of 10 times the square root of 10 is the square root of 100, which is 10. And then you had to multiply it by that 2 that was out there. So 10 times 2.
We're done.
Well, almost. We got to know if we need to be positive or negative. What was your question, Macy?
I was gonna say.
Okay. All right, let's look what quadrant that would be in. Between pi over 2 and pi is here, which is quadrant 3. That's quadrant 2 done, but quadrant 2. And in quadrant 2, we are, our cosine's negative, and our sine's positive. Negative, positive. This cosecant is the reciprocal of sine, and sine's positive, right? So this would be stay a positive. Okay, that's the more important stuff of this lesson, right? That stuff, those last couple of problems that we did. I feel pretty good about those. What do y'all think? Good deal,
I
good
just
deal.
have to be slow.
That's okay. Slow and steady wins the race. Tomorrow we're going to have our last assignment of the 9 weeks.
So we're done.
Yep, we're right now. Yes, ma'am.
Since I'm going to go on bed, do you want to fix something?
No, I'm not fixing that.
Did you tell us?
Did I tell you what? I have to tell you.
I know, but
How many days
nothing
in
was
a-
done.
You told me that, and I went and checked, and you were on, Classroom open and Spotify open.
Are you sure?
I went and checked when you told me that.
Oh, yeah.
Yeah, then I got a little irritated at you for telling me a story.
Well, I didn't know. My Chromebook's always dead, so that day then I had to just not know how to do it. I mean, for real.
How many days in a